So now we're going to work through a couple of examples involving the equation of a sphere. So first one, find the equation of a sphere with a diameter having endpoints of the order triple 2, 3, 8 and -4, 7, -10. So what I'm going to do is try to help you conceptualize this by using our two-dimensional rendering of a sphere. And once more, giving a shout out to my alma mater of Albion College. Woo! Go Brits! So if you know endpoints of the diameter of a circle, similar to what you would see right here. My handwriting has been atrocious recently because I have not been writing anything by hand. So endpoints of a diameter. Diameter is defined as a chord of a circle that actually passes through the center. So by this, what we're going to try to do is say that the center is going to be the midpoint of the diameter, and that'll be how we get our A, B, and C. And then the radius is going to be 1/2 of the distance from point to point. So what we'll do is we'll apply the distance formula to figure out the distance between these two ordered triples, and then we'll take half of that to be our radius. So for the midpoint of the diameter, we're going to be making use of the midpoint formula that was introduced in a previous video. That's where we're going to take each of the coordinates and find their average. So for the x coordinate, we'll be taking 2 plus -4. So 2 plus -4, put that result over 2. Then we're going to do 3 plus 7, put that over 2. And we'll take 8 plus -10 and put that over 2 as well. Simplifying each of these, 2 plus -4 is -2. -2 over 2 is -1. 3 plus 7 is 10. Over 2 is 5. And then 8 plus -10 is -2. Over 2 is, once again, -1. So these three numbers right here will be serving as our A, B, and C as defined in the last video. Now that you have the center, though, an additional way that you could find the radius is figure out the distance from either of these points to this point. In fact, that might even be a little bit easier for us, so we'll go ahead and change the plan for that one. This will be center to either point. So, applying our distance formula, this is going to be equal to, we'll be taking the square root of a change in x. Let's use the ordered triple, sorry about that, the ordered triple 2, 3, 8 as our x2, y2, z2. Then we'll use these numbers down here as our x1, y1, and z1. So with that in mind, we would be looking at change in x is 2 minus -1, quantity squared, plus, then we'll have 3 minus 5, quantity squared, and then we'll be doing 8 minus -1 and squaring that. So I'm seeing 3 squared. 3 squared is 9. -2 squared is 4. And that's 9 squared for 81. Put it together, we have the square root of 94. Now, do bear in mind, though, that when we're coming up with the equation of the sphere, we're going to need this thing squared anyway. And this was for the radius. So the equation of our sphere is going to be x minus -1, quantity squared. We'll go ahead and simplify that to x plus 1, quantity squared. Y minus 5, quantity squared. And z minus -1, quantity squared. So that'll be z plus 1. That's supposed to be equal to the radius squared. When we square that square root, the square and the square root will cancel out, and this is the equation of the sphere in question. And just by looking at it, we should be able to tell that the center is -1, +5, -1, and that the radius is the square root of 94. Now, there is another kind of problem that you could potentially see, and that kind of problem is going to be, rather than giving you the equation, or excuse me, rather than giving you the points, I will simply give you the equation and ask you to find the other aspects of it. So with that in mind, the equation of a sphere is x squared plus y squared plus z squared plus 12x minus 6y plus 4z plus 5 is equal to 0. Find the center and radius of the sphere. Now with that in mind, we've been given a more general form of a sphere, and what we're going to have to do is complete the square in order to get it into standard form that has all those nice completed squares. So first thing I'm going to do is rewrite this equation in a way where the x's are gathered together. We'll be completing the square on those. The y terms are gathered together. That's the y squared and the minus 6y. And then the z terms are gathered together as well. And I'm leaving a little blank space to complete the square on all of those. I'm going to take this plus 5 and move it over to the other side, just because that'll be contributing to the radius in just a moment. So process of completing the square says take the coefficient of the linear term, divide by 2, and square the result. If I add this number to these two terms, we will now have a completed square. So 36 for the x terms. Whatever I do to one side, I have to balance out somehow, so we'll add it to the right-hand side as well. Doing the same thing for the y terms, we'll get a negative 6 divided by 2, square that result. We are squaring negative 3. That is going to give us positive 9. And finally, doing the same for z squared plus 4z, we'll take that 4, we'll divide by 2, we'll square the result, and we will get 4 back. So what we're going to do from here is complete the square. Well, the squares are now completed, so now we can factor appropriately. This would be x plus 6, quantity squared, plus y minus 3, quantity squared, and z plus 2, quantity squared. Taking this negative 5 plus 36, that would be, 31, plus 9 is 40, plus 4 is 44. Now just by looking at this, we should be able to tell what the center and the radius are. Center will be the number that's being subtracted from each variable, so if you see an x plus 6, center is actually negative 6. Y minus 3, that'll be positive 3. And z plus 2, that'll be negative 2. Additionally, we take the square root of this number, we get the radius. Now, given that it is a radical, though, we do need to simplify that radical down to its most basic form. I can split 44 into 4 times 11. Square root of 4 gives us 2, and square root of 11 stays as the square root of 11. I do expect in final answers that if you give me a radius that is a radical, I would like the radical simplified, not rounded. So, hope you found this useful, and we'll see what more videos we need.